when we think about numbers, if you've done Gatenio or played the substitution game, you know that we can write. Now, this is not in Gatenio, by the way. This is a Vedic math thing. So you will not find this anywhere other than
what math?
Vedic math, VEDIC. So and here, the reason I'm doing it right in the middle of Gatenio is that both of them, the principles underlying both systems are the same. So Vedic math teaches everything from the position of algebra, and so does Gatenio. So we start with algebra. So we can rewrite, we know that we can rewrite 18 as 20 minus 2. So we could convert this, and we would just write it as this. 2, which is the 20, and then we're going to put this up here, and they are called bar numbers, and this up here is called a vernaculum. Not that you are ever going to get tested on it, but that's what that's, vernaculum. And these are called bar numbers. So this is 2, we would read that as 2 bar 2. And that tells you that this bar 2 is actually a negative number. So it's 20 minus 2. So how would we do 27 and write it as a bar number?
30 bar 3?
Yes. So we would write 3 bar 3. So it's just 30 minus 3. But 36. Julian's already been through this class, so this is all on your plate, Jenny, because no one else.
Oh, okay, great. I didn't want to just hog the conversation.
Yeah, go ahead, hog it.
40 bar 4.
So 4 bar 4, and then 49.
5 bar 1.
Gosh, that's pro at this already. All right, I'm gonna be a little trickier. 183. So what we're doing, we write bar numbers. Our goal is to steer clear of 6, 7, 8, 9. So when we write bar numbers, 0, 1, and 2 show up twice as often as they do with regular. So you get 2 times as often, you're going to see numbers that end in 0, 1, and 2, which is what we're looking for because we don't want to make we want fewer mistakes. So we probably over here will not convert. You can, but there's no need to convert this 3. So we would write it as we would write it 2 bar 2 and then a 3.
Okay.
So what you have is 200 minus 20. Or you can do a number split, and then you just have 20 minus 2. But that's still, when we do that, you have a visual of 20 minus 2 and then 3. But we're doing this at the very end because we want the kids to understand that this is not 20 minus 2, it's 200 minus 20. Mm-hmm. It's just that when it's on the other side of the bar, it looks like 2 bar 2. And we can treat it as 2 bar 2. All right, so let's do this one.
Listen.
Frankie, are you there? Can you convert this one to a bar number for me?
Yes, 25 bar 2. I mean, yeah.
25 bar 2. All right. So we don't have to convert the 48. We just convert this. We just turn this into a bar number. So what about 479?
Six 46 bar. 48 bar 1.
And what if I want to get rid of that 8 too?
What do you mean?
So you gave me this number. 4, 8 bar 1. but I want to get rid of this 8 also. So is there a way that I could change both the 7 and the 9 to a bar number?
4 bar 3, 8. I mean 9.
You mean 5.
Jesus.
Mm-hmm.
I mean 5. Yeah.
So we're going to do 5, bar 3, and then a 9. But what if I wanted to do the whole 7 and the 9 together as a bar number? So all of these are bar numbers. This is true. But what if I want this whole piece right here to be one bar number?
Five bar 2 1.
Ah. So we have 5 bar 21. So we're going to count all from 9 right here and last from 10 to get this bar number. So we count up to 9 and this one up to 10. So let's convert 5947 to a bar number. Jenny, I'm going to let you do it.
Okay, now I have to check my work because I did it before.
So if our goal, go ahead.
Is this is what I wrote already? 6 bar 1, 4 bar 3.
So it'd be 6 bar 1, and then it would be a bar 3.
Oh, 5.
Yeah. So we're gonna. She's doing a number split, and then 5
Okay.
bar 3. Yes. And then what about this last one? Who wants to tackle the last one? Anyone?
Ooh. Is it 2 bar 2? Ooh. I don't know.
So, okay, so let's look at it and evaluate it. So what is the closest? We got an 8, a 7, and an 8, a 9, an 8, a 7, and a 9, an 8, a 9, and a 7. So these are all over 6. So we can change this whole thing into a bar number.
Okay. So I don't split it.
We would not split it. We would just change all of it.
Okay, so 2 bar 1. Is it still bar 0?
Well, yeah, we would just we would put the whole thing in a bar.
Oh, okay.
Bar 3.
Bar 3.
So,
So 2 bar 103.
yeah.
Oh, you already wrote it.
Okay, so what does this have to do with subtraction? Bar numbers are fantastic. We can use them in multiplication. We can use them in division. Anytime you don't want to deal with a 9, you can change it into 6, 7, 8, or 9. Change it into a bar number, and then convert them back when you're done. But that is for a different. The later step is for a different class. We're going to do some subtraction with bar numbers now. And we are going to dispense. The only thing we need to know is all from 9, last from 10, and we don't even really need to know that. It just makes life easy. So Frankie, give me a top number. Make them kind of lower. Don't make nothing over 8, other than the first number. So you give me a top number. Make it 3 or 4 digits.
Okay, Frankie is outside blowing his balloon and
Okay, so you give me one.
okay. Say the requirement for the first number of
A 3 or 4 digit number, and none of the, other than the first number, none of the digits higher than 8.
okay 1 5 2.
Oh, I was saying the exact same thing.
Okay, whose voice is that? I was going to say the exact same thing. Whose voice was that?
Sorry, that's my son talking
Okay,
about
so-
something totally not related.
Oh, okay. I was gonna say, okay, you give me a bottom number.
He's trying to get the television cord so he can go watch TV.
Okay. All right. Well, never mind. He can't give me a bottom number. All right. I need a bottom number that is, let's do 2 digits, or I'll do it. Here, let's just do 87. So we're going to just straight subtract this like you see lots of little kids do this, right? They will say 7, well, we can't subtract, so I'll go 7 minus 2, and I'm going to put a 5 down. And they'll do 8 minus 5, and they're going to put a 3 down, and then they're going to put a 1. Lots of kids do this, and this is actually a fine way to do it if we put a bar number there. Because 7 from 2 is -5, and 8 from
Are you writing
5.
something? I don't see it.
You don't see it?
I
Is
see
every-
it.
Okay, now I can see the pen.
Okay. Can you see over here? Can you see where I wrote?
No.
Okay,
no.
so it's probably outside of your screen area. Here.
Okay, I can see it now.
Okay. 87, we're going to subtract, and we have, this is what they will write. And this is true if, because 7 from 2 is -5, and 8 from 5 is -3. And so all we would need to do at this point is convert that. These are bar numbers, and we would just convert it. So if we convert it and we remember all from 9 lasts from 10, what will our answer be?
65.
6. So 3 to 9 is 6, and 5 to 10 is 5. So is that clear to everyone, what I just did?
Yes.
We're going to do another one. Can you see all the way over here where my pen is, Union?
Yes.
Okay. So let's do 2, I don't know, 6, 5, 1, 4, and we're going to take, I don't know, 1, 8, 3,
7.
7. What do you want to do? 6? Okay.
Yeah.
All right. We're going to subtract these two. And what will we have here? 6 from 4 is,
Bar 2.
we'll put it, yep, bar 2. 7 from 1 is
Bar 6.
bar 6. 3 from 5.
Bar 2.
Is it a bar? I think it's just a 2. We can subtract 3 from 5.
Oh. Yeah, I don't see that number now only.
Okay, I have it written down here. Hold
Oh.
on. I will erase this one and okay, try again. And then I will select this and just move it. And does that help?
Yeah.
Okay. So 3 from 5 is 2. 8 from 6 is
Bar
2.
2.
Yeah, bar 2 and 1. So now we have 1, 2, 2. Well, we can 1, 2, 2, and then 1 bar 2, 2 bar 6, 2. So we can convert this, and we will do, the easiest way would be to do a number split here. So 10 minus 2 is
8.
8. And then we have a 2, but that'll become a 1. And then all from 9 last from 10 on 6
38.
is 30 and 8.
Do you do the number split there because that 2 is not a bar 2?
Yes.
Okay.
If it were a bar 2, I wouldn't do a
Right.
number split at all.
Okay, great.
Because you're throwing in here all from 9 last from 10.
Right.
And so you'd want to do your split here because this one is a 10 and this one is a 9.
Right.
So and the goal is, so once we do this enough times, you have to convert. After doing this, I don't know, 20, 30 times, they should be able to most kids do this in their head without having to do the conversion. You can just look and see if we had, let's say we did 5, because most of the time you're not going to be looking at that. We're going to be looking at numbers like 534 minus 487, right? And we can see right here, this is 3, and it's the last digit. And this is also a bar number. So this is the last one. This is going to be our 10, right? So we know this will be bar 3, and bar 3 is the same as, if it's from 10, it's going to be a 7. So this one's going to be bar 9. Or it's going to be, we're going to convert it. This is not a bar 9. This will be bar 6, but we got to count up to 9. So bar 6 is going to be 3. Well, sorry, I'm having trouble talking. This is not bar 6. This is bar 5.
Okay.
So bar 5, I'm going to count up to 9, and that will give us 4. And then this is going to be 1 less, so that'll be 4. So this is 0. So that's going to give us 47.
Okay.
So if you don't listen to how I talk, can you figure this out?
Yeah.
I'm going to go again. Try that one more time.
Yeah, I think the kids, if they do the supplement with rods, and then they could figure this out after they do this more. They could figure out it in their head.
Right. We do that, but I think it's important to write it out first multiple times so you can see. One, we need to know where we're making mistakes. So, and then after you've written it several times, I think it's pretty easy to do this in your head. So let's do 5,237, and let's take 2,359. This will be one big bar number. All right. So do we want to write it out, or do you want to do it in your heads?
I'm going to write it out.
Okay. So let's write it out. So let's do, well, we can go right this way then. So we can go 3, and then we have 3 from 2 is 1, 5 from 3 is 2, and 9 from 7 is 2, and these are all bar numbers. And then we will want to convert that, and when we convert it, this will be 1 less, so that we have a 2, and then here we have all from 9 last from 10. So 1 will be 8 to get to 9, 2 will be 7 to get to 9, and 2 here, because the last one is from 10, will be 8. And this one would have been a particularly nasty one to do with the standard algorithm, because we would first have to borrow here, and that converts to a 2. This is now 17. Well, this isn't enough, so we borrow here, and then that one becomes 12. And then we borrow here, and that's a 4. This was 11. Now here we go. And this, if you're a boy, is, okay, hold on just a second. Can you guys hold on a second?
Yes.
Okay.
Jenny, how old are your kids?
I have from 19 down to 3.
Oh, okay. So how many do you have?
We have 10 altogether.
So the 19 is he, which grade is he?
She just graduated last year.
Okay.
Yeah.
So
And
you,
what about you?
I only have one. He
Okay.
will be 10 next
Okay.
month.
Okay.
So you homeschooled your 19 all the way from the beginning?
Yes, we did. And then the last, like her last high school year, she did classical conversations. Are you familiar with that?
Yes.
Okay.
You mean her last year?
She did her last 3 years in classical
Oh, okay.
conversations.
I don't know how that works because I thought a classical conversation, it requires a lot of memorization. I know a lot of families do that
Yeah, well, they
from the
have
beginning.
different levels. So the one that you're thinking of is for their elementary age. They do what's called foundations, and it's a lot of memory work. And then their junior high and high school levels are called challenge, and those are more interacting with the material. And yeah, so it's kind of two different programs, and most people I think are more familiar with their elementary age.
Yeah. So I don't know. So you did not do the classical conversation from the beginning, but that will not impact any for the higher grades, right?
Correct. Yes.
Okay.
I mean, it made it slightly harder for them. You know, they didn't have those memory pegs like children who'd gone through it multiple times, but they did really well, and it really allowed them to interact more with material instead of just kind of regurgitation. I think this math method is just like, it fits beautifully with like a classical kind of model.
Okay.
I agree, by the way. Charlotte Mason. It's really right up there with Charlotte Mason too.
Yes. Yeah, exactly. I'm actually, very Charlotte Mason combined with memory work from classical. So yeah.
Yeah.
And we can't see your face
Can't?
anymore, Sonia. No. Just
Can
like
you see?
the top of your head.
Yeah, we can only see your ceiling.
Well, here. Let me go back so I can see. Oh, there we go. Hold on.
There.
All right. All right. Can you see you can see the whiteboard, right?
Yes.
Okay. Yeah. All right. Do we need to do another one? You want to do another one? Because one of the things I wanted to do today, we have a half an hour, is to just take some subtraction problems and look at different ways to solve them. And obviously doing the bar numbers is certainly, like, that becomes really easy and probably the default method for most kids once they get older. But prior to that, it's really helpful to start looking at other ways to solve the problems, especially since it's really the same principles you're using in algebra later on. So do we want to do more with the bar numbers, or do you want to just do some random subtraction problems?
Random sounds good to me because it's helpful for me coming into this to know when to use, it helps me to see when to use different methods.
Yeah. So most of this is probably going to be up to your kids when to use what method. So so this is how Gattegna would present these problems. He would do something like this. Let's do two-digit 27, and let's do 18. So he's going to present this to the kids, and then he's going to say, how many ways can you find to subtract this? How many different ways? So Frankie, are you there?
Yeah.
Okay, so you give me a way, and then I'll have your mom give me a way. Well, I'll go around and see if we can each find a different way to solve it. And you only get one way. You can't give us 5.
It could be 10 bar 1.
So 10 bar 1. So 1 bar 1, and then that'll, okay, and that converts to 9. So we'll do, all right. So Union, your turn.
My turn. I will do, okay, 27 minus 20 plus 2.
Minus 20. So it'll give you 7, and then we're going to add 2, and that's going to give you 9. All right. I'm going to go 27, and I'm going to just take this 18 and subtract it from 20, and that's going to give me 2, and then I'm going to add it to the 7. Oh, that's what you did. Hold on, I can't do that.
I have one.
So, well, hold on, I'm not done yet. Not done yet. I'll let you go first. I won't pick your method. You go first, and then I'll have to.
Okay.
Go ahead.
So 27 plus 2 minus 18 plus 2.
27 plus 2 minus, it's not the one I was going to use.
Good.
So she's got 29 minus 20. So it's going to give you 9. So I'm going to go ahead and I'm going to do all from 9 last from 10, but I'm going to do it differently. I'm going to take this 8 from 20, and that's going to give me 12. This will be 1 and 1, that'll be 0. So I'm going to do, so basically what I'm going to do is kind of what Union did a little bit, but I'm only going to take the 8 from 20, so I'm going to have, so how this is going to work, so it's going to be 27, and then we're going to take away, so we got 17 minus 10, and that'll be 7, and then I got 8 minus 20, that'll be, that's not going to work. Oh, yeah, it will, because this will be 7. No, it's not going to work. So I'm thinking here. Hold on. This will work. Got to think about it a little bit. 7 minus 18. So, oh, because that's just, all right. So 12. Oh, yes. So 20. So I can do this. So here's what I'm doing. Figure out what I did wrong. So I'm going to take the 8 from 20, and that'll be 12. And I'm going to add the 7 to it. So I'll have 19 minus 10, and that'll be 9.
Oh my.
So that was a little hard, but it still works.
Or you could just do 20 minus 8 and plus the 7 back.
Well, you can, but I couldn't do it that way because you already took it. So I had to come up with a new one.
No. I mean, you use 20 minus 18 and you plus 7.
Oh, okay, because you did 27 minus 20, added 2. So I agree, because, so I was going to do the 18 minus the 20.
Yeah, sorry.
2, but you did
somebody blowing the balloon.
That's okay. So I had, that my original plan was to take 18 from 20 and then add 2. But then I looked up here and saw that you had 27 minus 20. So yes, right. So that was a much easier way to do it, my original plan, and then I got confused with what Union did. So it was my original plan was to do 18 from 20, that's 2. So, so 20 minus 18. And then that's 2, and then I'm going to add this 7 over here. So 27, or so that's 9. So I can do 20 plus 7. All right.
Well, another way is that you just add that 27, add 1, and then minus 1, you subtract 18.
So hold on. Let's write this down. So you did 27 what?
27 plus 1.
So you had 28.
Yeah.
Oh, yep. And then you subtract it. And now we have 18. And we know that we added 1 up here. So now we have to subtract it here. So we got 10 minus 1 equals 9.
So for the different method, that's you use the method of supplement, and you use the method to make sure that the digit is bigger or as big as the one you're going to subtract. And
Philip would do it this way. What you just did, he already does that stuff mentally. So he's getting pretty good at that, like shifting stuff in his head thing. I'll just add it here and then I'll just take it away at the end. All right, let's do another one. Union, want to give me a problem?
okay, I just give one 345 and subtract 78.
Okay. Jenny, I'm going to let you go first.
Okay. So I got 3 bar 33.
3 bar 33. And that equals
267.
267. All right, Frankie, your turn.
Okay, I'll give him a minute. I go ahead.
Okay.
I would do 348 and then I would go plus I changed that to the 78. I would change that, minus 100 bar 22.
Okay, hold on.
Yeah, that's 348, 45, not 48, I'm sorry.
Okay. Minus 1.
100, bar 22. So when that bar 22, you just add it up.
Right, so we have 5 minus negative 2. So what is 5 minus negative 2?
Well, you just add it up.
Okay, so, right. And this one you're going to subtract.
Is 3.
Did you see what happened there, Jenny?
Yes. I'm just trying to figure out why it's 2 and not 3, or not 1. I mean, I know why mentally, but why did we? Oh, because the bar is down below. Okay. I think I understand.
So when we subtract a bar number, we've got a negative of a negative. So, right?
Mhm.
So it's going to be positive. We're just going to add these up.
Yeah, no, I understood that part.
Okay, so what part were you? And this one is, because it's not, this one obviously is going to be straight subtraction.
Yeah, I think that's the part I was because before when we were doing bar numbers, we took
Is it
the one
something-
off of the, like in the hundreds place in this case, but I think that was when the bar number was up top.
Well, there would be, so here's, so she's not converting, she converted this number to a bar number, and then she just subtracted, and she didn't end up with a bar number because this would be one less, right?
Okay.
But she's not converting this bar number. She's actually going to subtract the bar number. So here we have,
Okay.
does that make sense to you?
I think so. I mean, I think I would just need to play with it more to fully own it, but yes.
I've never thought about doing it this way, Union, and that is brilliant. And I don't know
Yeah,
why I've not thought of doing it that way, but like, of course you could do it that way. Why couldn't you?
Yeah, just like you play that a little bit and it will just come naturally.
Yeah, of course. I mean, of course you could do that. Why couldn't you? You can do it with division and you can do it with multiplication. So of course you could do it this way. All right. So it's Frankie, it's your turn.
Yeah, he's he waited and he's already outside now.
Okay. Was it my turn?
Yeah, your turn.
Okay. So I'm going to, let's see. Well, 345 and 78. And I'm going to just do all from 9, last from 10. So I'm going to have a 2 here, and I'm going to have a 2 here. I'm going to subtract, and this will be 1 less. So this will be 267. So I just did all from 9, last from 10. Common difference here, I think, would be a little bit trickier. You can do it, but it's adding 22, and that's not necessarily so bad. It would be 367 minus 100, and that'll give you 267. But once you're doing that, you might as well just go here, because that just seemed to me easier. But some kids will prefer this method, to do it this way, to add the common difference.
I think the more complicated is that the combination of a bar number, of a big number with bar number inside. And I mean, well, that's for the older kids after they play a little bit.
Yes. And some kids, just for the fun, will want to make it more complicated, just to solve the problem, just for fun.
We did, but once then we ended up some tears because I was just a little too complicated, and we tried to break it up. And then sometimes, we lost some of the where we break it.
But doing it, finding ways, and keep going until you can find more and more ways. What other things could you do to solve it? You know, if you can find 10 ways, even if they're the complicated ways, it really helps you understand how math works.
Yes.
It helps you play around with place value. So, you know, then this is one of the ways you can play with the little kids, is let them go first. You know, if you have the easy numbers, and let the ones that have no common difference go first, and work your way up to the older ones. I know Lacey does a lot of, she said that their family lives on the substitution game because everyone can play. All right, we find another way to do this. I mean, we could go, because I can do this one. We can do.
we could go 300 minus 78 and plus 45.
Yep, I was heading there, but wrote the 7 down. So you go 300 minus 78, and that will give us 222, and then we're going to add 45, and that is 267. We could do 100 minus 78, and that will give us 22, and then we can add 245, and that will give us 267. Obviously, we could do it from 200 too if we felt like it. These two make the most sense, but we can still do it with 200, and that does count as another way to solve it. Anything else? Should we do another one?
Jenny may want to come up with another one.
No.
All right, your turn to write the problem, Jenny.
Oh, I could write a problem, sure.
You can write as wild as you want.
Okay. 10,000.
Oh gosh, she's
531 minus 8,896.
all right. You get to go first.
Yeah, I just had to come up with all those numbers.
All right, you can go first.
Okay. Well, I could just do 10,531. Let's do the same and minus. And 9.
Yeah, I really, converting this one to a bar makes it really easy.
Yeah, because they're so close to 0. They're so close to 10 each digit. 104. No, that's 104 is the bar. Yeah, so
So then we have 1 here,
6,
6, 3, 5. And why I like this, doing it this way, is because it really makes it easy to go left to right. Just
Yes.
really makes it easy to calculate left to right. All right, I will go, and I'm going to do 10,000 plus 531, and I'm going to subtract 8,896, and I'm going to get 1,104 and 531, and now I have 7. Like, I don't know where these numbers come from sometimes. I'm going to just, 1 plus 0 is 7. So there's that. 1, 6, 3, 5. All right.
It's your turn, Jenny.
Okay, well, good, because so I just did 2 bar 365.
Okay. So
Just kept
2.
it the same. Yeah.
Okay. So you just subtract. So, okay. So, hold on. All right. And then we'll just convert that. And we'll do 1, 6, 3, 5, 9, 9, 10.
Yeah.
And one less. All right. Any other way, Union?
Yeah, we can do the way that Philip likes, but the only thing is that this one has 3 digits to add back, so that makes it a little more complicated than 2 digit or 1 digit. I mean, the way Philip likes to add that 5, 3, 31, just add 300, 365. But then we're going to subtract it.
So 896.
96.
And then 896. And then we have, obviously,
Two.
That's an 8.
2,000. Yeah, we have 2,000 left.
Yep. So we have 2,000 left. And we have to subtract. What did we add?
565. 565.
I think we added, we subtracted 365.
No, 365. Yeah.
Yeah. I was like, that can't be right. It's got to be a 3.
Yeah, right. That's
Right, and then we could do all from 9 last from 10 here. So we have 1, 6, 3, 5. All right, I'm looking again. Let's see what else we can do. Well, we can do, if I add, let's see, this is a harder one, but we can add 104, and that would be the common difference. So 6, 3, and 5. And then we add, and this will be 9. We add that here, it'll be 9,000. Then we have 1, 6, 3, 5. And that was just adding plus 104. But either way, we got a 104 here, we've got the 104 here. I mean, either one. Depends on when you want to add it. All right. So Gatenya will do this, and he will do the same thing with like addition. He'll give you, I'm about done with this. He'll give you a string of numbers, 27, 58, 36, 92, 121, and he'll say, come up with as many ways as you can think of to add these numbers. So he does the same thing with subtraction. So that's what you want to do and get them. And then he'll say, which way did you find the easiest? Which way did you make the fewest mistakes? Like, so it makes them aware of how their brain thinks, and their brains aren't going to, your kids' brains and your brains don't work the same way. So what's the easiest way for you to solve it is not going to be the easiest way that I would solve it. And it's interesting to me when you get into a group of people and you ask them what an answer was, and then you say to them, tell me how you solved it. If you have 6 people, maybe 2 of them will solve it the same way, and there won't be more than 2 people that solve the problem the same way. They'll all do it differently. All right, any questions?
No.